Just before we start the second part of our trig limits, just a quick reminder that we have limits that are for continuous functions and limits that are for not continuous functions where you have 0 divided by 0. So the second part of the lesson now is going to be about this where you have 0 divided by 0. Sine of 0 is 0. So sine theta over theta is a 0 divided by 0. And with reciprocal, it's still going to be 0. This is the graph of sine theta over theta. And what we want to talk about again is what happens as you approach 0. What's happening as you get closer and closer to 0. As you get closer to 0 from the left side, we're approaching 1. As you get closer to 0 from the right side, we're approaching 1. So that's what this information is telling us here. So what do you get then? Wherever you have sine theta divided by theta, you get to replace that expression with 1. So this 0 divided by 0 is going to equal 1. And we get that from the graph. We're not going to do any kind of proof for that. We're just going to use the graph to be our answer. The second thing we're going to use as kind of truth or as an identity is what happens when you put 0 in for cos theta minus 1. So cos of 0 is 1, 1 minus 1 is 0. So that's 0 on the top and 0 on the bottom. So this 0 divided by 0. Again, the graph as you approach from the left side, as you get closer to 0, is getting closer to 0. And the graph as you approach to the right side is getting closer to 0 as well. So you're approaching 0 from both the left side and the right side. So this 0 divided by 0 situation is going to be 0. So these two properties are key properties for us simplifying identities where they're not continuous. So let's go to some of our examples now. So again, I just kind of highlighted here, this 0 divided by 0 with sine thetas and this 0 divided by 0 with cos thetas are the key to us solving. So we're going to do a few examples where we're going to throw some graphs up here to look at the answer graphically. And then we're just going to talk about the algebra for some of the other ones as well. So first of all, sine theta over 2 theta. When you graph it, the graph now is only approaching a height of a half. So it's like we've taken our original function, sine theta over theta, and we've vertically stretched it by a half. So the answer is a half. And that's actually the math we're going to use, is that when you have a vertical stretch in a function, that vertical stretch can be embedded in the function or it can be outside the function. We want to be able to show the math that we can pull the vertical stretch out. So this sine theta divided by theta, this 0 divided by 0 gets replaced with the 1. And then you have the half. So 1 times a half is a half. So you have the math matching the graph. This is very different in B because this 3 now is a horizontal stretch, and you can't pull horizontal stretches out. And again, when you think about a horizontal stretch, it's about the period being way less than it was before or longer than it was before. So here's our function of sine 3 theta over 3. And it's kind of a neat looking function. And you can see now as we approach 0 from the left side, we're coming up to 3. As we approach 0 from the right side, we're coming up to 3. So the answer is going to be 3. What's the math that proves the answer is 3? Our property is theta divided by theta or x divided by x. In this case, I've got a 3 theta. I need my 3 theta to be divided by 3 theta. So this in the square brackets now, sine 3 theta over 3 theta is the sine theta over theta idea gets replaced by 1. So the purple becomes 1. What you learn in math when, I don't know, math 20, math 10, math 5, something, is that you can't just multiply the bottom of a fraction by something. You actually have to make sure you don't change the value of the expression. So whatever you multiply the bottom by, multiply the top by as well. So this 3 on the bottom gets canceled out by this 3 on the top. But again, you're not canceling them out. It's like using your factoring skills. You're getting an expression that equals something and you substitute for it. So here's the math then that basically justifies why the answer is 3. So if you ever have a situation where you have horizontal stretches, you got to put things into the expression. Where you have vertical stretches, you can factor things out. And then a lot of the other examples that you're going to see are all about just some algebra skills. So for C, sine squared is sine theta times sine theta. Theta on the bottom is theta times 1. So here's your sine theta over theta, which is the one expression. And then now you've got a second part of the expression, which is no longer dividing by 0. So to divide by 0 is where you use the identity. The not dividing by 0 is where you use trig skills, and then you simplify. If you get an example like D again, is not dividing by 0, so you just plug and go. Question E is very much like trig identities back from Math 30. We don't have any formulas for tangent being a limit, but we know if you put 0 in here, you get 0 divided by 0. So how do you do the simplifying on this one? Well, here's where you use your identity skills from Math 30. Sine theta over cos, sine x over cos x is tangent. Excuse me. Simplify your expression, right? If you're dividing, you multiply by the reciprocal, the signs cancel. So this is like the algebra. What you were able to do here is actually cancel out the sine x. You're able to cancel out the factor that's causing dividing by 0. And you get a situation now where it's not dividing by 0. You plug in, you simplify. Questions like f, where they're more complicated, f is really an extension of b, except for now you don't have a denominator with your sine 4x. You don't have a denominator with your sine 3x. So I need to put my sine 4x over 4x and my sine 3x over 3x. And then again, what I have to understand is that this 4x and this 4x really cancel each other out. So I put nothing into my expression. This 3x and this 3x cancel out. So I put nothing into my expression. So this sine 4x over 4x is going to be a 1. This sine 3x over 3x is going to be a 1. When I put a 4x into the top of my fraction in the numerator, and I put a 3x in the bottom of my fraction, the denominator, these two x's, just like you did in algebra in chapter 1, that factor of x and that factor of x cancel out. So that's why it's just 4 and 3 here. So you can see the answer is 4/3 in the expression. You can see the answer is 4/3 in the graph, but you need to be able to show the steps. And you just can't go straight from the answer or from the question straight to 4/3. We expect to see the sine theta divided by thetas, the sine theta divided by thetas, the proper math then that justifies the canceling of the dividing by zeros. And I guess we got a couple more examples we can go through. G is not a dividing by 0. Substitute and go. H is basically the exact same question as we just did with F, except for now we added some squareds to it. So if you take the squareds out of the expression, sine squared, right? So the 3x over 3x times by 3x, the 4x over 4x times by 4x's, the x's cancel. I get sine of 3x over 3x is the 1, sine theta over theta, cos theta over theta, those are 1s. The 3 and the 4 are here, the x is canceled, and this is squared. So your answer is 9/16. And then we keep on going with our last couple of examples. Double angle identities. All right, cos of 2x is an identity. You are given a formula sheet. You don't have to memorize these in high school, but those of you that are moving on to post-secondary, you're going to have to memorize some of these things. So here's an example now of an identity, replacing cos of 2x, using your algebra and canceling out the factors. So very much like chapter 1, factor out, cancel, factor and cancel. And then for J, tan of x, tan of 2x, again, an identity. Simplify. Dividing by fractions means multiply by reciprocals. Here, the tan x and the tan x cancel out. This is your dividing by 0, this is the 0 divided by 0, the tan x cancel. And then you get to plug in your 0 and simplify. All right, so a lot of things that you're going to do in this lesson are going to require your trig identity skills. They're going to require some factoring skills like you did back in chapter 1. So, hey, some Shrek math coming on. We're adding some layers. All the best in this one. This is a fun one. I really like this identity idea.